In this chapter of the Pragmatic Clean Architecture course, we're going to be solving authentication, and I'm going to use an external identity provider that is called Keycloak. Keycloak is an open source identity management system, and it offers a rich set of functionalities that we can use. However, I'm only going to use it to obtain a JSON Web Token for an authenticated user, and then we're going to use this JSON Web Token to authenticate with our API. In simple terms, I'm going to show you how to set up Keycloak as an identity provider in our system and then integrate it with .NET. This is the Keycloak website where you can learn more about the Keycloak service and what it offers. Essentially, it's a way to add authentication to your system with minimum effort. Most of the examples that deal with authentication show you how to create your own JSON Web Tokens and then use them to authenticate with your API. While I do believe there is value in understanding how all of this works, you don't want to be responsible for implementing a custom identity system in a production environment. There are excellent services out there that solve this problem really well, and Keycloak is one of them. It's also open source and we can run it inside of a Docker container, which is why I decided to use it as an example in this course. So let's see how we are going to integrate Keycloak into our system. I'm going to start by opening up our Docker Compose YAML file, and I'm going to add the service configuration for our Keycloak instance. I'm going to be using this Keycloak container. I'll give it a name of Bookify Identity, and I'm going to set up the administration user and password. And then this part is really important if you want to easily follow along with this chapter. I'm defining a Keycloak import, and I'm telling Keycloak that it should look for this JSON file inside the container and import this realm. A realm is a logical concept in Keycloak that manages a collection of users. You can think about it like a database which contains our users' information inside. The realm that we are importing is called Bookify, and I suggest that you download the source code for this chapter because it's going to contain the file that contains our realm export inside, which we're using to map to the appropriate file inside of the container. Also, I'm configuring a volume so that the internal Keycloak database is persisted in the case when we shut down the container. Lastly, I am exposing Keycloak on the localhost port of 18,080. With this in place, you should be able to start the application by running Docker Compose, and then if we head over into Docker Desktop, you're going to see that our Compose instance is starting up, and here is our Bookify Identity container that is running our Keycloak instance. Now if I try to navigate to the localhost 18,080 address, you should be greeted with this screen, and you're going to know that Keycloak is working. Sometimes you need a little patience because the container instance takes a little while to start up, but when it starts, it's working pretty fast. Here you have links to the Keycloak project website and also the documentation for the RESTful API for managing users. We're going to be using it later in the course to register our users, but for now, let's head over into the administration console for Keycloak. We need to provide the username and password for our administrator account, and we set those up in our Docker Compose YAML file, and now we can sign in to the Keycloak admin management system. If the realm was properly imported, you should see the Bookify realm here. The default realm is called master, and remember that this is a logical collection of users in our system. We're going to be using clients to authenticate with our Keycloak identity provider. I prepared two different clients. One is the Bookify Auth client, which we're going to use for generating our JSON Web Tokens. One is the Bookify admin client, which we're going to use for accessing the admin API of Keycloak. I won't go into detail about setting up these clients because this is out of scope for this course. Now let's go ahead and create a dummy user so that we can test our Keycloak login. So I'm going to add a new user. I'm going to give it a username and an email. And for both values, I'm going to assign test@test.com. I'm going to set the email verified to on, and let's create our user. Now I want to give this user a set of credentials, and let's just give it a password of 123. I'm going to set it to off on the temporary flag, and let's set this password. And now I'll head over into Postman. In the identity folder, I have a post request that is configured to hit our Keycloak instance. It's using the auth client, which I showed you earlier, and the appropriate client secret. The grant type that we are using for our request is password, and I'm specifying the username and password of the user that we just created. If I send this request to Keycloak, I expect to get back an authenticated response. You can see that we get back a response containing an access token, when it expires, a refresh token, and an identity token. Let's take this access token here and head over to jwt.io. I'm going to paste the access token that we got back from Keycloak, and let's examine what we have inside. So you can see that we have a subclaim. This is going to be important because this is the identity of the user in the Keycloak system. We're going to need a way to connect this identity to the user in our system to be able to properly authenticate the user. You can see the issuer is our Bookify realm on the Keycloak instance, and it contains a lot of additional information. Here's the email claim, if the email was verified or not, and what scopes this JSON Web Token has. There's a second request here. It uses our admin client and the client credentials grant type. It specifies the client secret, and if I send this request, I'm going to get back an access token which I can use to authenticate with the Keycloak RESTful API that's going to allow me to manage my users on the Keycloak system. Now I'm going to show you how to set up JSON Web Token authentication on our API, and we're going to be using the JSON Web Tokens that are generated using Keycloak. Let's start from the Bookify API project. We're going to introduce the middleware that is required for authentication. This requires two simple method calls. We need to call useAuthentication and then useAuthorization to add the necessary middleware. Now let's move into the infrastructure project to set up the rest of the things that we need. I'm going to start by adding a NuGet package, and I'm going to search for JWT, and I want to install Microsoft ASP.NET Core Authentication JWT Bearer. I'm going to install this NuGet package, and let's open up the dependency injection class. The add infrastructure method is slowly becoming overwhelmed with the amount of services that we have inside, so let's give it some structure. I'm going to take these calls here and move them into a separate method using the extract method refactoring. Let's call these add persistence, and I'm going to hide the add persistence method for the time being. Let's add underneath our configuration for authentication. We're going to call the add authentication method, and you can optionally set up the authentication scheme. You can access the authentication scheme exposed on the JWT Bearer defaults class, and the value of this constant is bearer. I'm also going to call the add JWT Bearer method, which you can use to set up the JWT Bearer options. It has a lot of important properties which are used for validating access tokens, but I'm going to show you a different way of properly configuring the JWT Bearer options class, which is not going to involve providing a delegate here. So here's what we're going to do. I'm going to add a new folder in the infrastructure project, and I'm going to call this folder authentication. Inside of this folder, I'm going to add a class which is going to represent my authentication options, and this class is going to contain the following properties. We need the audience of our JSON Web Token. We're going to need the metadata URL, then if we require HTTPS metadata, and who is the valid issuer for our JSON Web Token. We're going to obtain these values from our application settings, and I'm going to add them in the application settings development JSON. The section name is going to be authentication, and here are the values that you would need to set with the current configuration that we have in place. The valid issuer and metadata URL are both pointing to the internal Keycloak instance that is running inside of a container. The valid issuer is our Bookify realm, and the OpenID metadata is available on this route. Now we need to configure our authentication options instance, and we're going to do that by saying services, configure, and then passing in the authentication configuration section to the authentication options class. We also need to configure the JWT Bearer options, and I'm going to use the configure options approach by providing a class that implements the iConfigure options interface. I'm going to add that class inside of the authentication folder, and this is what it looks like. we're going to implement iConfigure named options and specify the JWT bearer options as the generic argument. Then we need to implement two methods, which are the configure and configure method with a name. And the benefit of this approach is that we have support for dependency injection, and we are injecting our authentication options instance using the options pattern. Then I'm using the authentication options that were provided through our application settings to set the appropriate values on the JWT bearer options type. And now we are ready to enable authentication on our API endpoints. I'm going to open up the apartments controller, and we're going to decorate it with the authorize attribute. Let's hit this endpoint from Postman and see what is going to happen. I'm going to send a GET request to the search apartments endpoint, and we're going to receive back a 401 unauthorized response because we aren't passing in a valid JSON web token. This tells us that authentication seems to be working correctly, but to be able to tell, we need to generate a proper JSON web token. Let's go ahead and implement the user registrations and login flows, and then we're going to obtain an access token that we're going to use to authenticate in our endpoints. Let's start by implementing the register user feature in the application layer. I'm going to create a feature folder that is going to hold our users features, and the first feature that we are going to create is going to be to register a user. Let me add a nested folder inside and give it the name of register user. The command is going to contain the email, first name and last name, and the password of our user that we are trying to register to the system. Then I need to add a respective command handler for this command, and this is what the command handler will look like. Currently, I'm missing the iAuthentication service, which I will add in a moment, but let's observe the handle method. We are creating a new user by calling the user create method. We're passing in our first name, last name, and email to the value object constructors, which are required to satisfy the create method. Then we're calling the authentication service, which is going to register our user with Keycloak and is going to give us back the identity ID, which we are going to set on the user entity before persisting it in the database. I'm not implementing any validation to check if the user with this email already exists because I want to focus on the use case itself. Let's create a new folder under abstractions, which is going to hold our authentication services. And I'm going to introduce one interface inside, which is going to be our iAuthentication service. It accepts a user instance and a password and an optional cancellation token, and is going to return back the identifier of the newly registered user. If I head back to the register user command handler, you'll see that everything is okay now, except the handle method which we are missing. So let's go ahead and create this method, and inside of this method we are going to set the property on our entity, which is going to be called identity ID. This property doesn't exist at the moment, so let's give it a value, and I'm going to place it next to the other properties in the user. I'm going to give it a private setter so that it's the same as all of my other properties, and I'm going to assign it an initial value of string empty because it's not set through the constructor. Now if I head back to the register user command handler, everything is going to compile nicely inside of our use case. One more thing that we should have for every command in our system is a respective command validator. So let's take a look at the register user command validator. I'm doing just simple input validations here, checking that the first name, last name, and email are not empty, or confirming that they are a valid email address. And for the password, I'm defining a simple strength rule that the minimum length of a password has to be 5. Before we tackle the authentication service implementation, let's define our endpoint in a controller.